Hi, my name is Ihsan Zadkar and welcome to Neural Network Principles in Matlab Essential Training. In this course, I'm going to teach you neural network principles and its application in Matlab programming. During these videos, we explain the application of the neural network and different functions used to construct and train a network for such an application using different examples. At the end of this course, you will be familiar with the network structure and its components, and how to control these components in Matlab Toolbox. Also, you will be able to use proper network structure for your specific application, and train that function with proper training algorithm. In general, perceptron networks, linear networks, and backpropagation networks is explained using different examples. First of all, you need to install the software. You can purchase the software directly from MathWorks website or use the trial version of the software. So, if you have the software installed on your machine, just sit back relaxed, go to the next movie, and enjoy the course. Matlab, which is abbreviated of Matrix Laboratory, is a multi-paradigm numerical computing environment and a fourth-generation programming language developed by MathWorks. Although Matlab is intended primarily for numerical computing, but by optional toolboxes using the MU-PAT symbolic engine has access to symbolic computing capabilities too. One of these toolboxes is Neural Network Toolbox. This toolbox is a free open-source software for simulating models of brain and central nervous system based on Matlab computational platform. As the name of the toolbox implies, the main goal of this package is to provide users a set of integrated tools to create models of biological neural networks and simulate them easily without the need of extensive coding. Neural networks are composed of simple elements operating in parallel. These elements are inspired by biological nervous systems. As in nature, the connection between elements largely determine the network function. You can train a network to perform a particular function by adjusting the values of the connection between elements. These elements are known as weights. Although the complexity in artificial neural network could never be compared with the biological one, but there are some similarities. Both are composed of simple tools with complex connections of them, and the power between nodes indicates the transfer function of the whole system. Neural network is a proper tool at function fitting and pattern recognition. We will show you how a simple function fitting is accomplished in Matlab. To define a problem to the toolbox, two vectors must be arranged as columns in matrices. These two vectors are input and output vectors. Suppose we want to define input-output vectors in a Boolean AND gate problem. In this problem, we have a 4-set, 2-element input vector and a 1-element output vector. In the next movie, we investigate a more complex problem and define its input-output vectors. Then, using command line functions and using graphical user interface, neural network fitting tool and neural network tool, a network will be trained to be fitted in the problem. In this movie, we are going to investigate the neural network in function fitting problem. It can be proved that any practical function can be fitted by a simple neural network. Now, we are going to construct and train a network in a housing problem. The final network is supposed to be able to predict the price of a house according to 13 features which is learned in training process. This problem is solved using neural network by command line functions. At first, we need to construct the input-output data. To do this, we must load the dataset by typing load house dataset. As it can be seen, two matrices are added in workspace named house input and target, which are input-output we wanted to construct. The input consists of samples representing 13 features which influence the target, which is representing the price of a house. Now we are going to use command line functions for the problem. Using the function newFit, house input, house target, and 20, we construct a feed-forward network with one hidden layer consisting 20 neurons and one neuron for output. Of course, it's possible to use more neurons in hidden layer in more complex problems, but at the expense of more complexity. The function uses the tangent segment function as its default and is known as a proper function in function fitting problems. To train the constructed network, the function train is used. This function trains the network according to the input and output data using Levenberg Marquardt as its default, and splitting a dataset into three categories: 60% randomly chosen for training, 20% randomly chosen for testing, and 20% chosen independently for evaluating of the network. As the training process starts, a window opens to show the process. You can stop the training by clicking Stop Train. In this example, the training process stopped as the validation error increased for 6 iterations. The performance button plots the performance in train, test, and validation data. The final mean square error of the training is small. The characteristics of the test and validation error are the same and no significant overfitting occurred, so the result is reasonable. The regression key applies a linear regression between network output and the corresponding targets. The following figure shows the results. So, as the output is tracking the target in test, train, and validation sections, and the regression value is over 95%, the results seem to be good. But to get more accurate results, you can increase the number of hidden neurons, training vectors, or the number of input values if more information is available. Finally, to examine the trained network against new inputs, the function sim can be used. The new inputs rows must be equal to house inputs.